Hello. Now let's have a good look at the transformation. Here we have a square root function, okay? Gx equals to minus half square root of 6 minus 2x plus 1. Now, you see this has got all kinds of transformations in it. This is vertically reflect on x-axis. It is vertical compression by a factor of half. And inside, we just don't know exactly what it is. We need to factor this out. And this is vertically translate 1 unit up. Now, this factoring, you have to be very careful. Whenever you see something like this, it is important to write x with just coefficient 1. Whatever is before x, here in this case, the coefficient of x is minus 2. You need to factor out minus 2, rewrite your equation in the standard way, and then look for transformations. Else you may not get the right result. So that's a common mistake which are seen in the test papers. So be careful. You need to hone your factoring skills. So review them. Now let's rearrange and write it in the right way. Here it is. Let's rewrite this equation after factoring. So I can write Gx is equals to minus half within square root. I am going to take minus 2 common, okay? So get minus 2 x. So once I take minus 2 common, we are left with x. And then I am going to divide 6 with minus 2. When I do so, I get minus 3. So I get minus 3 square root plus 1. So that's our function really. Now here you can say, what are your horizontal transformations? This minus indicates reflection on y-axis. And 2, remember, inside we just do the reverse. 2 is more than 1. We don't stretch. We compress it by a factor of 1 over 2. Do you remember that k factor? Compress by a factor of 1 over 2. And this minus 3, you have to move your graph 3 units right, horizontally. Correct? So, the transformation finally we are looking for is reflection on x-axis, vertical compression by a factor of half, horizontally reflect the graph on y-axis, horizontally compress the graph by a factor of half, 1 over 2, horizontally translate the graph 3 units to right, and vertically translate the graph 1 unit up. Correct? Now the order of operation is the second important thing which you need to consider. One, I prefer going from left to right. If you go from left to right, do this, 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 this and this, you'll never go wrong. Well, we'll however follow another technique here, inside out. These horizontal things are kind of complicated. So I know we have to do multiplications first along with reflections and then translations. That is the basic rule. So you can either go for vertical stretch compression reflection first, or you can go for horizontal stretch compression reflection first. It's your choice. Here I will go with horizontal compressions and reflection and then vertical. And then we'll do the translations, okay? Now, I hope you understand that. Now, before we really graph it, we need a set of points. Now, from where to get those set of points? Well, square root function. You know what is the domain of this square root function? There is no harm in checking the domain of our final function also. Let's do that part also. Now, to find the domain of this function, we know we can start with the original. You might have done some wrong calculation here, correct? So let's start with our original and find what should be the domain of Gx. So to find the domain of Gx, inside term should be greater than or equal to 0, correct? So we'll do this. 6 minus 2x should be greater than or equal to 0, correct? So now I will bring 6 this side and then see what happens. Or I could bring minus 2x this side. I'll prefer bringing 2x this side, minus 2x. Reason being, if I bring 6 this side, I am left with minus 2x. Next step is divide by minus 2. But when you divide by minus 2, most students forget to change the sign. That's another mistake. Well, so we can do that way. But remember, if you divide or multiply by minus, you got to change the sign. I'm not taking these chances here. So I will do this. So I have 6 greater than or equal to 2x. Now what is x? I'll divide by 2, correct? So I have, when I divide 6 by 2, I get 3 is greater than or equal to x. Or I'm trying to say x is less than or equal to 3. So our domain is, what is our domain? Domain is x is less than or equal to 3. Is that okay? That's our domain. Now, let's take some points and see how to transform a function. I'll adopt 2 methods in this particular case so that you understand transformations very well. Now, one is, okay, so let me just take it like this and draw a line. Let's take the original values here, xy of our original function. So what is our original function fx? Original function fx is square root of x, which is transformed. And then once we transform, we get our gx, which is equals to minus half square root minus 2 x minus 3 plus 1. Is it okay? Correct. So what happens to our transform point? See how x values and y values are going to change in gx from fx. Gx is image of fx. Now, as far as x points are concerned, only the inside values change the x points. So let's look into the transformations. Here we are multiplying it by a factor of minus half because it's reflection on y-axis and a compression by a factor of half. So x becomes minus half. I'll write here minus 0.5 x minus half. Half is 0.5. And then we move 3 units to the right. That means we add 3 to our x value. When you move right, let's say you are here, you move right, it is as good as putting plus 3 for x. Is that okay? So that becomes our new or transformed x coordinate. How about the y coordinate? Y coordinate gets multiplied by a factor of minus half. Correct? So we write minus 0.5 y. It only affects y, not x. Plus 1. Plus 1. So that gives the new point for our y. Is that okay? Yes. Now, which are the good points to take for a square root function? As you studied under the video, we saw that for square root function, the good points are 0, 0, 1, 1, 4, 2, 9, 3 and so on, because they give you non-decimal values, correct? So let's take those values. 0, 0, 1, 1, 4, 2 and 9, 3. Square root of 9 is 3. That's what we are trying to say. Square root of 4, so x is 4 and y value is square root of 4, which is 2. Now see how these points get transformed. Let's do our maths. 0. Let's put 0 for x and then calculate. 0 times anything is 0 plus 3 will leave us with 3. For y, 0, first factor is 0 and we get 1. So this origin, the vertex of our square root function, which was in this case the absolute minimum, got transformed to this value. Correct? Now, when you put 1, minus 0.5 times 1 is minus 0.5. Plus 3 gives us 2.5. And 1 for y value, minus 0.5 plus 1 will give us 0.5. 4. Now when I do 4, half of 4 is 2. Minus 2 plus 3 gives us 1. And when you put 2 here, minus 1 plus 1 is 0. Correct? Now let's put the next value, 9. X value 9, half and minus 4.5 minus, plus 3 minus 1.5. How about 3? Half of 3 is 1.5, minus 1.5 plus 1 gives minus 1.5. Minus 1, 3 half is minus 1.5. So minus 1.5 plus 1 gives 0.5. Correct? So that's our value. So these are final values. So what we could do is, first we can draw our square root function, the original function. The points here are 0, 0. Let's focus on it. 1, 1, 4, 2. So 1, 2, 3, 4, 1, 2. Eliminate 5 here. 6, 7, 8, 9 and 3. 1, 2, 3. So that's our original function, square root x. Now I could go straight into the final values and plot them, correct? But here I will show you transformation in two different ways. So now I will do stepwise sketching of the graph and show you how really it gets transformed. That'll be fun part, okay? So as I said, we will start from inside. Now inside is horizontally, we are what? Reflecting on y and then compressed by 2. So first let's reflect it. So when you reflect these points, they come here. Do you see that? This is like 4 and 2, so it becomes minus 4 and 2. The y values don't change, but x2, 1, 2, 3, 4 and 2, correct? And this one is 9 and 3, minus 9, 5, 6, 7, 8, 9 and 3. There we go. So for this function, the graph looks like, I'm not drawing it dark because too many lines will be there soon. Okay, and this is definitely not our final. This is just the first shot. Now, we will do horizontally compressed by a factor of half. What does that mean? That means that you bring them to the half distance. So we bring it half distance here, and half of 4 is 2, you know, and half of 9 is 4.5. So 4.5 is here for us. Correct? So we will join these, and this I'll slightly make darker than the previous one, showing that I have transformed and done two operations. That is, I reflected the graph, original graph, square root x. So this was square root of minus x, and this is square root of minus 2x. So at this time, what have I done? I have reflected, that is minus, and then compressed my graph halfway through to reflect as minus of 2x. So we are done with the horizontal part of this, right? Now let's look into the vertical stretch and reflection. So first, let's reflect these points. So once I reflect this, it comes here. Now the y values change, not the x values, right? So this is at 2. Let me bring down this point at minus 2, okay? Minus 2. And here, this is like 1, 2, 3 units. Let me bring down 1, 2, 3 units down. Correct? So we have a graph here which is, I should now write minus of minus 2x. Correct? Now we will do compression by a factor of half. Compression of factor of half will bring it half units up. closer to the x-axis, right? Y value is halved. So this becomes here, and this is at 3, so it comes at 1.5 halfway, correct? So that's my half. So I will do this a bit darker to show you that we combine these two vertical things, and now we got our function minus half square root of minus 2x. So by this time, you see, we have already done our horizontal and the vertical stretches, compressions, reflections, all those multiplication part is over. What is left for us is translation. So let's translate. So translation is 3 units right, 1 unit up, correct? So let's do that. 3 units right and 1 unit up. So for each point we will do 3 units right and 1 unit up. So this vertex of ours will move 1, 2, 3 units right and 1 unit up. So we get this point here. Is that okay? And how about this? This point goes to 1, 2, 3 units right, 1 unit up. So this point gets there. Do you see that? This point goes here, right? Now here, 3 units right. So 1, 2, 3 units right and 1 unit up. This is kind of dicey, but this is the point here. Do you see that? Yes, it is. Now let's join them and draw a graph. This is our function, and this function is the very final gx. Do you see that? So gx now is equal to minus half square root of minus 2 x minus 3 plus 1. Correct? Now how do we know it's real and it's correct? Let's check our values. We did the transformation. We could have done it in one step, just moving right from here to there. Okay, these red points we will check. Do they agree with us? Okay, first value 3 and 1. So let's check this value 1, 2, 3 and 1. So the image of 0, 0, image of 0, 0 is 3, 1. Do you see that? Next point 2.5, 0.5. Now 2.5 is and 0.5. 1, 2, 2.5 and 0.5. Let's check this value. For x, if I put x as here minus 0.5, we get 2.5, and for 1, half of this is minus and you get 0.5. Correct. So 1, 2, this is 2.5 and 0.5. So this should have, this kind of is very close, right? There's a sketching error, but that's the point. You are right. And then we got 4, 2 gets transformed to 1 and 0. So 1 and 0 is here. Yeah, that's very close to a graph. 1 and 0 is right there. And then 9 and 3 is minus 1.5 and minus 0.5. So minus 1.5 and 0.5 is right here. Perfect. So all 4 points are there. I didn't show you how to get to this. Well, that's okay. It's on the graph. That's a good check. So finally, this red line indicates the transformation of our function. Do you see how easily we could do it? But you have to follow the steps, else you could go wrong. And there are so many ways you could go wrong. Correct? Some people, they just start off with this and they really don't know where to land in this kind of a function. Now, even in spite of doing correct factoring, you could go wrong if you don't do stretches and compressions first and mix up with translations. Correct? If you move first here and then reflect, then that reflection will be like putting your graph on this side and the whole scenario will change. So take care. Don't do those kinds of mistakes when you're doing such a complicated graph. It is probably one of the most complicated scenario which you are going to face in transformation at this level of grade 11. Okay? I hope you understand and follow the steps to do a good job of transformation. Okay? Thank you. Have a close look. Again, watch the video if there's difficulty, and then once you are ready, then try some examples on your own. I can give you a few examples here. For example, you can do these functions. 1. You can do hx equals to minus 2 square root of, this time let me put half here, okay? X plus 1 minus 1. And then you can have another function. Here I did the factoring for you. And now I'm not going to do factoring for you. Let me write here without factoring, okay? Another transformed function fx as half. There's no reflection in this case here. Why I'm writing half, not 1 by 3? Because that gives you too many points, decimals. It's very difficult to do those decimals. And you can't accurately graph it. If you get 1 over 3, change your scale. Instead of scale having a division of 1 and such, make it multiple of 3, okay? Then, let's say if your scale has this as 1, then 1/3 is the first unit, correct? You need to change your scale if you get 1 over 3 such factors, okay? So, let me give you where factoring will be a key thing for you. Minus 4x plus 1. So here you need to factor this, correct? Why am I giving you only square root functions? I could give you, quadratic functions and other functions. Mainly because in square root functions we have very limited domain and range. And if you do a mistake, you really go wrong. Here you need to find the real domain and check your values. Last example, I forgot to show you that. Do you see x is, what is the domain here of our function and what is the range? So domain here is x belongs to real numbers where x is less than equal to 3. It is what we expected. And how about the range? Range here is, I always write x, it is y. Y belongs to real number and y is less than equal to what value? 1. That's what you should expect, right? 1. So you moved up and then reflected. So the graph came down from 1. So less than equal to 1. Do you see that? Here you moved 3 units to the right. Therefore, x should be less than 3. So that's our domain and range. And it's very important to write domain and range of our transformed function. Correct? So for the time being, these are good examples for you to try. Get used to your square root function and its transformation. Fine. Thank you. I hope you learned a lot from this video. Thank you.